This unit is going to be on similar figures and primarily triangles. We focus on triangles, but other similar figures have the same basic ideas. So some things that we have to make sure that we're very, very clear about. Two figures are similar if all of their corresponding angles are congruent. Now, we haven't talked about some of this stuff in a while. So corresponding angles means angles that line up. All right, so angles that line up. So the angles are all going to be congruent, meaning the angles are the exact same size. The deal is the size can be different. All right, so if you look down here a little bit more, it says similar figures are the same shape. That's the angles, but different sizes. That's the size. We're going to talk a little bit more about what that means in just a second. So the angles have to be the same. The sides do not. One of the big things to look for is the symbol for similar. So the symbol is just the top part of the congruent thing. And basically what that congruent thing ends up meaning is the top part stands for the angles. The bottom part stands for the sides, the distances. All right, and when you have the angles and the sides both completely the same, you have congruent things. When you have just the angles the same, but the sides not the same, you have similar things. All right. Now, a couple quick things here. So similar figures are going to have a scale factor. Now, we'll talk about this, but not probably until the third or fourth day. You're going to see a scale factor abbreviated with an SF a lot of times in problems. All right. These are going to be used in proportions, which we have not done a ton with this year, but we've done some. All right. So determine the measurements of missing sides. So sides always have a scale factor. There's one scale factor for any similar figures. It might be 3/5. Okay, and then we use that scale factor to be able to cross multiply and figure out missing sides of similar figures. So right here, write down sides are not equal. All right, because if you're the kind of person that has just really set things equal and hope for the best throughout the year, for similar figures, that works very rarely. It works for angles, but most of the questions are going to be about sides, which means if you start setting things equal, you're going to get most of the questions wrong throughout this unit. The last little evil trick that gets thrown in here is we say similar figures have the same shape but different sizes, and there's one exception. All right, so this is the one thing that if you really, really want to make sure that you fully understand similar is the only thing that's required for similar figures is that they have the same angles. Okay, the sides don't have to be different for them to be considered similar. All right. So the one exception is when the figures are congruent, they're also similar. And that's kind of weird because if figures are similar, they're probably not congruent. But any congruent figures are similar. All right. And what that means is they'll have a scale factor of 1. We'll talk about this more when we get into the sides. We're going to do angles first, and then we'll deal with sides. So we'll come back to this. All right. But really for right now, what we want to understand is similar figures have angles that are the same. That's the most important thing. Their sizes are going to be different pretty much every single time you do one of these problems, all right, with maybe one or two very rare exceptions that we have to look for. Similar figures can be confusing just because of the proportions. The angle stuff we're going to do first does not have proportions in it, so we're going to focus on that first, make sure we understand the angles as well as we can, and then we will deal with the proportions and the sides, and we'll spend a lot of time just talking about how to set the proportions up, because if we can't set them up, we cannot get the right answers.